Hey there, Patriots. Let's go ahead and get started on Unit 5. The good news is that we only have this one and one more unit left to go before the end of the semester. That's right, we only have 6 units, and we got 4 already under the bag. That's 2/3 already finished, and so let's get this one done. Unit 5, we're going to be focusing a lot on applications of how to use lines and linear equations. And we're going to start off with really diving into standard form a little bit more. I know I told you guys that it was the least useful of all of them. And while I still say that that's true, we are going to go over some of the ways that we can use it. I never said it was useless. I said it's not as helpful as the other ones. So let's go ahead and go through here. And let's go ahead and review what standard form is. So standard form is when we have an equation written in the form ax plus by is equal to c, where a, b, and c are integers, which means that it can be positive or negative whole numbers and 0. So that's one that's like this: 9x plus 4y equals 36. And we're going to focus a lot on graphing those in the first part of this lesson. So we got 3 steps here. First one, we want to isolate our variable, solve for y. We want to transform to the form y equals mx plus b, and that's what we see down here in step 1. From there, we're going to identify our slope and then also identify our y-intercept. Once we know our slope and our y-intercept, we're then just going to graph. So let's see what we need to do in order to isolate y. Now I want to get this y by itself. The way I'm going to do that is by subtracting 9x on both sides. Now if you remember back in, I think it was Unit 3, we had a page where we did this exact same process like 4 times all down the left-hand side of the page. Exact same thing that we did there, we're going to do here. This 4y is going to get written down equals, now again, I can write these in any order as long as the 9 stays negative and the 36 stays positive. So I'm going to write that as negative 9x plus 36. Now I'm going to divide everything by 4, and that's going to leave me with y equals negative 9 over 4x plus 9. So now let's go ahead and identify our slope out of that. M equals, remember that slope is the number in front of the coefficient of x. So that is going to be negative 9 over 4. Our y-intercept is the number that is added or subtracted on the end, the constant term, which is 9, which remember we write as the coordinate point 0, 9. Okay, now let's go ahead and graph that. First thing we do, go to the y-intercept, or the starting point, which is at positive 9 up here on the y-axis. Then we're going to apply our slope, negative 9 over 4. Now, negative slope means that as I go from left to right, it's going to go down. So it's going to go this direction. Again, what would slope do today? We're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, and 4. Now I'm going to go in with my straight edge, and I'm going to draw that line. So we're going to practice that a few times, and we're going to do it the same way for all 4 of these examples that we have here. So 2 plus 3y, 2x plus 3y equals 18. Draw our line here. We're going to start off by subtracting, let's get the right color and do the right number, subtracting 2x on both sides. That's going to leave me with 3y is equal to negative 2x plus 18. Now we're going to divide both of those by 3. And that's going to leave me with y equals negative 2/3 x. 18 divided by 3 gives me 6. So again, slope is there. Y-intercept is here. So first off, we go to our y-intercept. I guess I should probably, no, the directions don't explicitly say to write it out, but I'm going to anyway. I'm going to write out my slope is negative 2/3, and my y-intercept is 0, 6. Okay, for graphing that, I'm going to go up to positive 6 on the y-axis. Now, again, negative slope means it's going to go down as we go to the right. So we're going to go down 2, right 3, down 2, right 3, down 2, right 1, 2, 3. And then draw the line. So there we go. All right, let's try this one. So negative 3x plus 4y. We're going to start off by adding 3x, add the x term to both sides. Leaves me with 4y is equal to 3x plus 24. Now, same as before, divide by the coefficient of y on every single term. Leaves me with y equals 3/4 x plus 24 divided by 4 is 6. So my slope is, coefficient of x is 3/4. My y-intercept is the constant term, so it is 0, 6. Same as it was on the last problem. Okay, graphing, same as before. I'm going to go up to the point 0, 6. Now we're going to apply our slope 3/4. This one's positive 3/4, so it's going to rise as we go from left to right. So we're going to go rise 1, 2, 3, run 1, 2, 3, 4. And I'm out of room this way, so I'm going to go back the other direction. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Go ahead and take my straight edge and draw my line. All right, number 3, same thing as before. We're going to subtract 7x on both sides. That's going to leave me with negative 5y is equal to negative 7x plus 35. Now we're going to divide both sides by negative 5. Leaves me with y equals, now negative 7 divided by negative 5 becomes a positive 7/5 x. 35 divided by negative 5 is a minus 7, or a negative 7. So let's go ahead and come up with our slope and y-intercept. Coefficient of x is 7/5, and the y-intercept, the constant, is 0, negative 7. Okay, so same as before. This time we're going to drop down 7 from the origin to plot the first point. Now we're going to rise 7. 1, 2, 3, 4, 5, 6, 7. Run 5. Rise 7. Run 5. And draw our line. Okay, last example of this type. Let's go ahead and subtract the 10x off of both sides. It leaves me 4y equals negative 10x plus 40. Now we're going to divide both sides by negative 4. And that leaves me with y equals, now negative 10 divided by negative 4 is going to simplify. That's going to simplify down to, first off, positive, and they both have a factor of 2, so that's going to be 5/2 x. 40 divided by negative 4 is negative 10. So again, there's my slope, there's my y-intercept. So slope is 5/2, and y-intercept is 0, negative 10. All right, so I'm going to go down to negative 10 on the graph, plot it on the y-axis. Now my slope is 5 halves, so I'm going to, from this point, rise 5 and then run 2. Rise 5 and run 2. And by the way, I'm able to do that without having to actually count it is because I'm just going by my 5 markers here. Those are really easy to see. So I'm going to go ahead and go 5 more and then run 2, 5 more, run 2, and then go ahead and plot that. Draw the line. So that's our first skill, which is graphing from standard form. Remember, first step, get y by itself. That's what we're seeing down here, the thing I wrote highlighted down in green. Then we're going to identify your slope and y-intercept, the purple and orange, and then go ahead and graph all of those lines. So next step next skill we're going to work on is taking a word problem or taking a scenario and writing it in writing it in standard form equations. Now, the thing you got to keep track of here is pay attention to what types of information you're giving, particularly when it comes to number concepts. Now, when I say number concepts, I mean, there's going to be things in the problem where they talk about how many students there are or how fast something is driving, something that is being expressed as a numerical value. You want to pay attention to what are those? And there are 3 types of values. We've got starting values, we've got rates, and we've got totals. Now, a starting value is where if for example, someone is charging to mow a lawn. They say, if I'm going to come out, I'm going to, my base rate is $35, and then I charge $10 an hour on top of that. Well, the $35 is the starting value. Okay. Now, a rate would be like saying $10 per hour. So that's how much we're doing per hour. Use the per is very, very common to see when we're talking about rates. Now, totals is if I add all of that up, how much does it sum to? Standard form, the telltale sign that something's going to be written in standard form is that it's going to have two different rates and a total. So you're looking for 2 rates and a total, and that tells you what and then you're going to be using standard form. If you see a starting value and a rate, that's going to be slope intercept. So let's go ahead and look at this. Paperback books are sold for $8 per book. Now, when I see this $8 per book, that tells me that that word per tells me that it is a rate. And hardbacks are sold for $16 per book. Again, I'm keying off of this word per, okay? If they spent $240, well, that looks to me like we're talking about a total there, okay? Write an equation to represent this situation. Now, this is also important. It says let P represent the number of paperback books and let H represent the number of hardback books. So we're not using X's and Y's, we're using P's and H's. Now, what you're going to do on this is you're going to take the number of paperbacks times its associated rate. So, number of paperbacks, we don't know how many that is, we just know that it is P. But the rate for paperbacks is, let's see, paperbacks are sold for $8 per book. So it's going to be 8 times P, 8 times number of paperbacks, plus, let's do the same thing for the hardbacks. We're going to have H for the number of hardbacks, and the rate per hardback is 16. Now, if I add all that up, the total cost of paperbacks plus the total cost of the hardbacks is how much you're going to have to pay at the register. That's how much money you spent. That is the $240. 8P plus 16H equals 240. Okay, now in a supermarket, apples cost 50 cents each. Now, this word each here is also another one that tells us we're usually going to be talking about a rate of some kind. So, apples cost 50 cents each. We also know that grapefruits cost $2 each. Again, we've got that each word there. If you want to spend exactly $15 at the supermarket, write an equation. Well, looks like we got a rate for apples, a rate for grapefruit, and then a total amount. 2 rates and a total, standard form. So let's go ahead and do this. We're going to be, says that A is our number of apples, and G is our number of grapefruits. So let's do our apples first. A is the number of apples times the cost per apple, which is 0.5. You could write it as 0.50. That probably would actually work out better since we're trying to talk about money here. And then plus 2 times the number of grapefruit. And again, this is money, so I'm going to go ahead and write it as 2.00 G. And that is going to equal the amount of money we spent, which is $15. Okay? Now, let's look at example 3. A 100-point test has X questions worth 2 points apiece. Now, here's another interesting word, that apiece gives us the exact same idea as a rate, sort of like per or each. So, we've got X questions that are worth 2 points apiece. I'm going to go ahead and underline that X. And a Y question, so we got a Y question worth 4 points apiece. Write an equation to represent the situation. Well, my first question is, where's the total? Well, we're talking about X is being worth 2, Y is being worth 4, but the total is actually up here at the beginning. It's the 100-point test because there's a maximum of 100 points on this particular test. So let's see. Let's do number of X questions, which is going to be, or times our rate is 2, plus number of Y questions, which is Y, and times its rate, which is 4. And then that is going to equal the total, which is, sorry, I used the wrong marker there, equals 100. All right, 2 more. Tickets for a concert cost $35 for a balcony seat. So we got $35 for balcony seats and $50 for floor seats. A group of 14 people, now I'm going to go ahead and underline this, 14 people attends the concert and spends $550 on tickets. Now it says, let B represent number of balcony seats, and then we've got F to represent the number of floor seats. Write an equation to represent how much the group of friends spends on seats at the concert. Now, I'm going to go ahead and put out there that there are 2 different standard form equations I could come up with here. And here's what I mean by that. I got to decide, am I talking about number of people or amount of money? Because let's do this first. What about number of people? Okay, how many people are going to be sitting in balcony seats? Well, that's just 1 person per seat, so that's 1 times B. Now let's talk about our floor seats. Plus, again, 1 person per seat means 1 F. And that is going to equal, what's our total number of people? Well, in that case, we've got 14 people, so that equals 14. But if I was talking about money, well, then that is slightly different because now I've got different rates. I've still got B for number of balcony seats, but now I've got a different rate. When we're talking about money, each ticket or each balcony seat costs $35. So it's 35 times B. Now, I've still got F for the number of floor seats, and those are actually $50. But I've also got a different total as well, because now the money total is right here, which is $550. So it really just depends on what the question is asking for. Now, I probably should have read this first before I did it. I just want to go ahead and point out that the exact same scenario could give you 2 different equations. But whenever I read this whole thing, I'm going to go through and see, write an equation to represent how much the group of friends spends. So how much they spend, that tells me I'm looking at money. So my answer is actually going to be this one I'm highlighting in blue. So just be careful whenever you got a lot of different things flying around. And sometimes you can have multiple equations that can come from the same scenario. You just got to pay attention to what you're focusing on. Okay, we're right at the 20-minute mark, and I want to go ahead and get this finished so you guys aren't having to watch this thing all day. Last example. A piggy bank is filled with nickels and dimes worth a total of 175. Now, we got to be careful with this one because we've got N as our number of nickels, D as our number of dimes, And it looks like I've got a total here of $1.75, but there are no rates. Well, this is one that we're expecting you guys to know by now, what the value of each type of coin is. So I'm going to go ahead and write in here my nickels. Well, how much is a nickel worth? 5 cents. Let's make sure that we're writing that with the proper decimal notation, so 0.05 for our nickels. Plus, our dimes is D, and that is going to be 0.10 times number of dimes for 10 cents per dime, and that equals $1.75. So be careful with these. Just make sure that you're looking at your standard form is just going to be rate times how many plus rate times how many equals total, or rate times variable plus rate times variable equals total. Follow that through and you shouldn't have any problems doing this assignment.